Greetings to everyone. Today we are going to discuss the rectifiers. So, starting from the definition to the types and then how each rectifier works. Okay. So, rectifiers are the basically integral parts of the power supply system. So, that is why let us look at the overview of the power supply, how it converts AC into DC. So, why we have to convert AC into DC is to most of the electronic systems work with the DC power supply. So that is why we have to, but available power supply from the government agencies are the AC supply. So that is why we need to convert AC into the DC. So that should be done in a step-by-step manner. So not in a single phase we can do. So we have to go with the step-by-step manner. So first we have to use transformer. So normally transformer is a step-down transformer. Here we will use. So that is why 230 volts RMS have to be stepped down according to the requirement. So that is done by transformer. So the input to the transformer is from the line voltage, that is 230 volts 50 edges, and the output of the transformer is again a AC only, but it is downscaled voltage of AC. So in the second stage, we will be using rectifier. So the input for the rectifier is nothing but output from the transformer, which is again AC. So the role of the rectifier is to convert this pure AC into a positive DC, as you can see here. So it is here it is shown half a rectified voltage. If it is a full wave rectified voltage, negative half also will be converted into positive half, something like this. Later in the next stage, we have to use filter. So the output of rectifier is fed as input to the filter circuit. So here we'll be using some reactive elements like inductors and capacitors will be used to design the filter circuit. So filter converts this further into improvised DC. Later we'll be using regulator. So the regulator will convert this waveform into a pure DC where you have zero frequency or zero ripples. So we won't have any ripple of the output of the regulator. So that pure DC will be connected to the load to drive. So that is why, that is how we will be converting a pure AC, that is line voltage, into a pure DC which can drive any electronic system. So this is the power supply. And now we are going to focus on the rectifiers. So here if you see, the rectifier is a device that converts alternating current AC, which periodically reverses direction, to direct current DC, which is in only one direction. The process is known as rectification. Means AC will have instantaneous values, but DC should have a constant value with respect to time. So that needs to be achieved here. So here if you see, now let us look at the types of rectifiers. So here if you see the types of rectifiers, we will be having half a rectifier, which will be using single diode, full wave rectifier, which will be using two diodes and center tap transformer, and then bridge rectifier, which will be using four diodes and a regular transformer. So these are three types of rectifier. Now let us look at half wave rectifier. So in half wave rectifier, either positive or negative half of the AC is passed through the circuit or to the load. Okay. So here we'll be using diode, which is a uni directional conduction will be there. It allows only one half of the waveform, other half of the waveform will be blocked. So we'll be using single diode, so half of the waveform will be removed from the output. So that's how half-wave rectifier filters out. Now let us see the working. As you can see here in this animation, where my input is varying from 0 to positive peak, and then it is again touching to 0, and it is going negative peak. From negative peak it is coming to again 0. But negative peak, as you can see, during positive half cycle the diode is conducting, so that is why we will be getting here output, positive output. But when it comes to negative half have been, as you can see. So here, this is the AC input where we'll be having instantaneous values. Okay. So it is coming from 0 to maximum value, and then it is again coming to 0. During this particular half period, there was a current flow through the diode. And for the negative half, there is no conduction because the diode is reverse biased. Diode conducts only for forward bias. So that's why if you look at the output, so here we'll be getting only two positive halves. So that is how this half-wave rectifier works. Okay. So this is my half-wave rectifier where this is the input, a pure sine wave, which is nothing but output of a transformer. So here this is the transformer stage, okay, where it will be reducing the amplitude of the voltage, RMS level of the voltage, and then we are applying it to the rectifier circuit. So this is the rectifier element what we are using. A diode we are using as a rectifier element, where we know the fact that diode conducts only for forward bias and it won't conduct for reverse bias. So here this is anode of the diode, this is cathode of the diode. So for positive half cycle, anode will be applied with positive with respect to cathode. So diode conducts, so current flows through the diode to the load. So that is why you will be getting positive half cycle. For negative half cycle, during this particular period of time, diode reverse biases, it acts as open circuit. So there will not be any current, and hence there is no voltage for negative half cycle. Again, it is coming positive half cycle. For positive half cycle, once again diode becomes forward bias, so that we will be getting positive half cycle of the output. So the period of the waveform is again same as the input. So but negative side have been removed. So that is how it acts as a half-wave rectifier. Now let us look at full-wave rectifier. So full-wave rectifier, we have two diode rectifier and a bridge rectifier also. Both are full-wave rectifiers. So two diode rectifier will be using center tap transformer, where it almost acts like a two transformers, independent transformers. But here we'll be using two diodes, D1 and D2. Okay. So here this is my D1, this is D2. Okay. Now if I look at, so in half-wave rectifier, for positive half cycle, diode D1 conducted, so that I have got positive half cycle. But unlike earlier case, we are using D2. So what happens with D2 is, if you take this point as A, this point as B, and the center tap is grounded. So for negative half cycle, what is the negative half cycle means? Point A is negative with respect to point B. Okay. So now point B is positive. So this anode is positive with respect to cathode. So this D1 act as open circuit, D2 act as closed circuit. So now my current starts in this direction, flows through the load. So this for negative half cycle. So here during positive half cycle, when diode 1 was conducting, the current have flown in this direction. So now the direction of the current, if you look at from the load, the direction is same, and hence the both half cycles will be getting positive half cycles only. Okay. So once again, I'll recap. So this is my positive half cycle where this is point A, let's say this is point B. Point A is positive with respect to point B. Okay. So diode D1 will be conducting, D2 will be acting as open circuit or reverse bias. So now current starts from A, flows through load in this direction and enters to the center tap. So here center tap, let's say it is grounded. So that's why my output is a positive half cycle. Now let us look at for negative half cycle of the input where my point B now will be positive with respect to point A. So D2 will be conducting, D1 will be open circuit as it is reverse bias. So now the current direction is like this. So earlier case also current have flown in this direction as far as load is concerned. So that is why even though input is negative half cycle, it's been converted to positive side. So now my entire waveform, so this is repeated by a period, input period. So now my entire waveform falls between 0 and positive maximum voltage. So that is how this acts as a full wave rectifier. Next, we will be having bridge rectifier where instead of center tap transformer, we can connect 4 diodes, something like a bridge, as you can see here. So for a positive half cycle, say here I have altogether 4 diodes. Let's say D1, D2, D3, and D4. Okay. So for a positive half cycle of the input, so this A is positive with respect to B. So diode D1 conducts so that current flow will be there like from point A to D1. Okay. And then positive terminal. So this is my closed circuit throughout the load. Okay. D1, D2 conducts. D3, D4 won't conduct, open circuits. So D1, D2 will be closed circuit. So if you connect load over here, now current flows in this direction. So that positive half will be transferred to the load. Now let us look at for a negative half cycle. So if you have negative half cycle, this will be positive, means if this point is positive. So my, let's say this is D3, D4. So these two will be conducting so that now the current direction will be like in this direction. It flows like this. Okay. So as you can see in this animation, okay. So as you can see this output voltage of the full wave rectifier. Now let us look at comparison of half wave rectifier, full wave rectifier, and bridge rectifier. So number of diodes in half wave rectifier will be using 1 diode. In full wave rectifier 2, bridge rectifier 4. DC voltage Vm by pi, 2 Vm by pi, 2 Vm by pi. So means DC voltage is doubled compared to half wave rectifier. Peak inverse voltage Vm, 2 Vm, and bridge rectifier Vm. So peak inverse voltage is nothing but the maximum reverse voltage that a particular diode has to tolerate when it is reverse bias. So that means when you are designing a rectifier circuit, what is the AV capacity of the circuit that you have to take. So that tells you about that. So here I have 2M. So expensive diode must be used for full wave rectifier compared to half wave rectifier. Ripple factor, which is nothing but AC content out of present in the output, 1.21 for half wave, 0.48 for full wave, 0.48 for bridge rectifier. Means half wave rectifier contains high ripple factor, means AC contents is more compared to DC. Rectifier efficiency, half wave rectifier less than 50%, maximum efficiency 40.6%, full wave rectifier 81.2%, and bridge rectifier 81.2%. Transformer utilization factor means how much power that is being utilized from the transformer in converting to DC. It is 0.287 of half wave rectifier, 0.693 for full wave rectifier, for 0.812 for a bridge rectifier. So as far as bridge rectifier is concerned, it is having more advantages. We are almost avoiding expensive center tap transformer. We are getting highest rectifier efficiency, lowest ripple factor, highest DC voltage, and then highest transformer utilization factor. And then form factor of half wave rectifier is 1.57, full wave rectifier 1.11, bridge rectifier 1.11. So these are the comparisons of different rectifiers. Thank you.